Hi dear students, how are you? I hope you're fine. Today we're going to talk about similarity in right triangles. So we are going to start with the warm-up. How can we write the similarity statement comparing the two triangles here in this triangle? I have here triangle as you see ADB and triangle ECD. Okay, so triangle ADB, this triangle is similar to triangle what? EDC. Why? Because we have here angle B is congruent to angle C. Angle here ADB, this angle 90 degree, and it's congruent to which angle? It's congruent to angle EDC. So we have here the two triangles are here similar. Why? Because the third angle here, angle E, is congruent to angle A. Why? Because we have the third angle theorem. If two angles here in the corresponding triangles are congruent, therefore the third angle here in the two corresponding triangles are congruent by the third angle theorem. What about this one? I have here this one 3 over x equal 5 over 8. So how can I solve this? Cross multiplication. 5x equal 24. How can I get the value of x? Divide both sides by 5 by 5y, the coefficient of x. So x here will be 24 over 5. What about if I say 2x here? Okay, 2x power 2 equal 50. How can I get the value of x? Divided by 2, the coefficient of x power 2 here is 50 divided to 25. What about x alone? Square root. So x will be positive or negative 5. 25 under the square root, what times what gives me 25? The same number, 5 times 5. Okay, here this one simplify. This is very easy. How can I solve this? We have 27 here under the square root. I see in the table of here 27. 27 equals 1 multiply 27. Here 1 multiply 27. Okay. 3 multiplies 9 gives you 27. And 9, here I can write 9 times 3, which is the same as 27. I can take out here 9 from the square root. 9 is 3 times 3. So I will take 3 out. I will take 9 out. After solving it, it gives you what? Gives you just 3. And take it out here. And leave the other 3 under the square root. So this is the simplifying of this. Okay, here we have the altitude to the hypotenuse of a triangle, of a right triangle, forms two triangles that are similar to each other and to the original triangle. Here in this diagram I have three triangles, triangle DCB, triangle DCA, and the big triangle ACB. The three triangles are similar. Let's see. The question here comes like this. Write the similarity statement comparing the three triangles. Okay, so the first step, I will sketch here the three right triangles. As I told you on the online session, what we should do, we will draw three triangles here. The small triangle, the larger triangle, and then the largest triangle. Okay. So we have here the big triangle, the largest triangle, which is UWV, this whole triangle. And where is here the right triangle? The right angle, it's WVWU, this one. So I'll draw it and draw here the right angle, and then I'll draw the inside triangle, which is ZWU. Okay, ZW, where is here the right angle? As you see, this is the right angle because it's stuck to the right angle here, 90 degrees. So this must be 90 degree. Okay, this is the second one. And then the third one, this one, as you see, ZWV, and the right angle will be here for Z. VZW, this angle, as you see here. Then I will write that the three triangles are similar, and this question is the same. What about here in this one, how to find the geometric mean? It's very easy. I have here, my dear students, if I say A over X equal X over B, then the cross multiplication, I will say A multiplies B equal X times X. When I say X times X, it means X to the power, right, 2. If you want just X, so I'm going to do what? I want to get rid of the squared. So square root of AB. Okay, square root of AB. Let's see. When it comes like question here, find the geometric mean of each pair of numbers. If necessary, give the answer in the simplest radical form. I have here two numbers 4 and 25. How can I solve this? I write, let x be the geometric mean. He asks me for the geometric mean. So x, let it be the geometric mean. Number 1 times number 2. Number 1, which is 4, multiplies 25. So I have here x power 2, don't forget the power, x power 2 equal 4 multiplies 25. So x power 2 equals, 100. I need just x, so square root of x here and x power 2 and 100 gives you what? Under the square root, here under the square root, it gives you x will be equal positive or negative 10, but we take only the positive square root. Okay, we take only the positive square root. What about this example? He asks me to find the geometric mean and give the answer to the simplest radical form. Very easy. My here rule, x power 2, let x be my geometric mean. So x power 2 equal 5 multiply 30. The two numbers, number 1 times number 2. Easy one, very easy one. So I have here 150. To the simplest radical form, and here square, here is squared. So I'm going to make the square root. Square root of here, so x equal square root of 150. 150 is what? 150 is 6 multiplies what? 25. Okay, 6 multiply 25 gives you 150. So if I say why 25 did you choose this? Because here 5 times 5 equal 25. Can I get the square root of 25 is 5, get it outside, and 6 remains under the square root. Okay, I hope you understood everything. I'll send you the homework on Google Classroom. Thank you for listening, my dear students.